This one's a little bit more interesting than number 5. I'm pretty sure we did this one in class. 2 times the cosine of 3 theta. If you draw an r theta chart, you start at 0. Let me be consistent with how I did it last time. Start with 0. Cosine of 3 times 0 is cosine of 0. 2 times the cosine of 0 is 2 times 1, so we get 2. And so we get the point right there. And as it turns out, if you plug in pi over 6 for theta, then you get 3 pi over 6, which is pi over 2. Well, cosine of pi over 2 is 0. So at the pi over 6 mark, let's do the pi over, that's pi over 4, and pi over 6 is right there. So if we were to draw the graph, we would see that right there, that line, it hits the origin, or hits the pole right there, at the pi over 6 radian mark, and it comes around here, and then it comes back around here like this, and then that's not a very good graph. Let's try that again. So it comes back around, and then the question is, what does it do right there? Which line is it tangent to, or which line is tangent to this curve right there, and which line is tangent to the curve right there? And if I'm consistent with how I did it in the last one, we had a tangent line in blue right there, we had a tangent line here, and then blue. So blue represents the tangent line. So the question is, what are the equations of those lines? Okay. Well, there's another way to do this. I mean, you could do it like this. You can go, all right, well, I know that this angle right here is pi over 6. Okay. I know that this angle right here is pi over 2, and I know that this angle here is 5 pi over 6 because of the consistency with the symmetry in the graph. And so if the angle is pi over 6, then I know that's 30 degrees, and I know the tangent of pi over 6 is radical 3 over 3, and so, radical 3 over 3, and I know then that the slope of the line is the tangent, and so the slope of the line is radical 3 over 3. And so therefore, y equals radical 3 over 3x would be the equation of that particular tangent line. That's one of the equations. Okay. Well, the other one, x equals 0, would be the second one. X equals 0. And that would be the vertical line that goes right through the origin. And then the other one, at 5 pi over 6, we know that the tangent of 5 pi over 6, and why are we using the tangent? Because the slope is always the tangent. Tangent is y over x. Okay? Tangent of 5 pi over 6 is radical 3 over 3, but negative. And so therefore, any line that goes through the origin has a y-intercept of 0. And we get the slope, which is negative radical 3 over 3, multiplied by x, plus 0. And so therefore, those are the 3 equations of the 3 lines that are tangent to the curve at the pole. Okay, well, how else could we figure this out? Well, let's go ahead and go over to the next slide, and let's see if we can figure it out the kind of like the algebraic way. We have r equals 2 times the cosine of 3 theta. Okay, well, when r equals 0, what is theta? Theta equals what? Well, if we want to know that, then we would just set r, which is 2 times the cosine of 3 theta, equal to 0. Dividing both sides by 2, we get the cosine of 3 theta equals 0. This is the one we did in class. And 3 theta then, if you look at a unit circle, where is the cosine equal to 0? Well, the cosine is equal to 0 up at the top and down at the bottom. So we have whatever the angle is has to be, okay, so to solve this equation, whatever the angle is, has to be either pi over 2, 3 pi over 2, and then you can keep going around. Just add a couple more. You don't know when you're going to stop in problems like these, so you just keep going. Just all the odd numbers times pi divided by 2. Okay. Well, we're not done yet because we haven't solved. We haven't solved for theta yet. We've only solved for 3 theta. So we have to get theta by itself by multiplying both sides by, and we should dot there, and we should multiply both sides by 1/3. So therefore we get theta by itself, okay, theta equals, and then 1/3 times pi over 2 would be pi over 6. And then 1/3 times 3 pi over 2 is pi over 2. And then times the next one, and we get 5 pi over 6. Times the next one, we get 7 pi over 6. But notice that the line y equals, or theta equals 7 pi over 6 is the same line as theta equals pi over 6. So these are the same line. Like if you drew the line theta equals pi over 6, again, it'd be the same line as theta equals 7 pi over 6. And the same thing is going to happen if you keep going. You'll just get duplicates of the first 3. So we don't need to worry about that third one. And in fact, these are the 3 angles that we found on the other page. Remember the 3 angles? We had pi over 6, pi over 2, 5 pi over 6. If we did 7 pi over 6, again, it'd be the same angle as the first one. And so we have the angles, we know the tangent of the angles, and I'll write that just below it. Tangent of pi over 6 is radical 3 over 3. Tangent of pi over 2 is sine of pi over 2, which is 1 over 0. It's undefined, so we get a vertical line there. Tangent of 5 pi over 6 is negative radical 3 over 3. And so vertical line means x equals 0. The other ones, y equals, and we already talked about that, negative radical 3 over 3x, and y equals radical 3 over 3x. Those are the 3 equations, and you can use this method or you can use the graphing method. The graphing method promotes more understanding, requires more understanding as well. So I hope you like the graphing method first, the one that I did first. That's why I did it first, because I'm hoping that you'll like that one better. All right.